Hello and welcome to Graphics, Gears, and Wires. This is Henry, and today I'm picking up my tutorial on the classic lander game in the Godot game engine, and I'm going to show you how the actual lander object works. So there's going to be some keyboard control, some particle effects, that kind of stuff. So let's get into it. So here in front of us we've got the lander object actually running, and I'm going to go ahead and run the scene. And what you see here is I can rotate the lander, and the thrust affects the lander, so I can move it around. And if I pass from one side of the screen to the other, it's going to wrap around for us. And if it goes below the bottom of the screen, it'll just reinitialize, which will never happen in-game, but it allows us to test it outside of a level, which adds to its reusability if we wanted to make a different game later. We're also using fuel now, and it has health, so if it was to collide with a surface, which isn't being rendered here, it would damage it. And I've actually written all of the game logic to handle completing a level when it lands on the pad, dying if you crash into the surface, that kind of thing. So I'll show you all that stuff next. So I'm going to close this out, and we're going to look right at first the particle effect. And how this game object is put together. I'm going to turn the particle effect on just so you can see it. And that's how you edit things in the editor, which is great to edit particles in this editor because all of these parameters, you can just play with them and see how they're going to affect the particles as they run in-game. So that's really cool. Really makes it easy to do that. Besides the particle effect, which I'll show you the whole particle effect here. So it's got a nice curve to it. I'll show you how to do that. Besides particle effect, we've got a collision polygon 2D, and that's what's going to detect any impacts with the surface or with the landing pad. And then we've got the polygon 2D, which is just the graphic representation of the lander, which we may overlay or replace with a sprite or a texture or something at some point. Okay, so here we are looking at the source code for the lander object, and at the top I've got a bunch of variables. You can see I've set two that I wanted to be able to adjust in the editor. So I've got this export variable and then the value. That puts it in the editor. I'll go ahead and show you that. If I unmaximize here, you can see when I select the lander object, I have the script variables, roll speed, max thrust. You do that by using this export format for the variable here. It's one of the things that makes GDScript different from regular Python is that there are little bits added to it to make it work well with the editor. So there's a little bit of things to learn that makes it a little bit different than Python. But besides those kinds of things and the difference in the match and switch statements, it's very, very much like Python. If you're comfortable in Python, or if you're even learning Python, this is not something that's going to derail you. This is going to be very, very much up your alley. So anyway, we have a bunch of variables defined. We'll talk about them as we step through the script. We'll start with the ready function. That's called every time an object is initialized internally in Godot. So it's automatically called. So I set the pause mode to pause mode stop here. And what that does is when I pause the whole game, which I do in the main game script, this tells the physics engine, hey, don't do anything with this object. That's important because when the game is paused, I still want the UI to run. I might still want some visual effect to run, like if I had swaying trees in a background, I might want them to run. And I want the main game loop to run. So as you see here, I've got pause mode stop in my surface and my pad inside the ready modes, and also in the main game, the pause modes are all process. So really when you pause, the only thing that's going to happen is the lander is just going to stop doing what it's doing. And that's going to let it retain its momentum and things like that much better than if you just stop the object by zeroing out all its properties or something. This will just retain all those values and pick them right back up when you unpause. So let's go back to here. Can sleep false. In the physics engine in Godot, in a game like Lander, when the lander settles and is resting on the surface, it might not be damaged enough to be broken, but it might stop responding because a physics object that is at rest can go to sleep. And I am updating I'm taking input inside of this physics process function, so there's no way to apply thrust to it if it's asleep. I could probably change where I'm applying that thrust to get around that, but it was just as easy to say, hey, don't put this object to sleep. I wouldn't set, if I had a bunch of objects, say we had hundreds of objects using the physics system, and I told them all, don't go to sleep. That's going to be poor optimization. In the case of this, we have basically 3 physics objects in the whole game, so I'm just not going to worry about that optimization. Once it's ready, it initializes. And when it initializes, we initialize it the same as we do all the other objects in the game, so that when we replay, without having to manually position things, it procedurally generates where they should start per level. And you notice before I've been doing seed and then just the level. Here I'm doing seed times 2. And the reason I did that is because using seed level for this and also for the pad script meant that the pad and the lander were always directly in line with each other, because I initialized the seed and then called random range on the same 50 to 1230, and they end up actually every single time being directly in line. So I'm just modifying the seed a little bit. Whatever we feed to the lander gets modified when we seed the random range. It's probably better to seed the random range one time at the beginning of the game. I'm not doing it that way because I want all these objects to be able to operate independently. So I'm seeding them all independently. That's just part of object reusability and being able to run them without having to have a parent object or a game attached. So we set the position to the random range, and it basically just sets that lander from left to right the same way the pad was set in the last tutorial. And we always set the position 50 pixels down from the top of the screen. The linear velocity at that point is 0. We're resetting it because we use this initialize function if we were to reload a level, start a new level. We call this, and it may have momentum from the last level that it was on, or it may have been in test mode, dropped below the bottom of the screen, and then we reinitialize it, set its position to a new position, but it still has its old velocity, so it would continue to accelerate indefinitely. So when we reinitialize, we set the velocity of the physics object to 0. I reset position is true, means we're going to update the position in the physics loop. I'll show you that when we get to the physics loop. We record the previous position as the position to show that this object has not moved. This position versus previous position is how we track whether or not we've landed down the road. So we're resetting that. Eye on pad is false, eye on ground is false, things that'll change when we impact the pad or the ground. And here you see if it's level 1, we reset the health and the fuel. But if it's not level 1, instead of resetting them, we'll add a fuel or health reward, and we'll limit that to being at least fuel plus the reward, or 100. It can't go past 100. So we're using the minimum of fuel plus reward or 100, and doing the same with health. Now in the physics process function, we start by zeroing our thrust and then turning off our particles every physics frame. And then we step through this function and say, if we've got fuel and we've got health, check to see if we should be using the thrusters. And if the input action is pressed for the thrusters, we're going to reduce the amount of fuel we have, multiply that by time so that on faster and slower computers, or let me restate that, multiply that by delta, which represents the time between frames, so that the amount of fuel we use when we hold down the button is the same on a slow computer as it is on a fast computer. If there's some variation in the frame rate, multiplying by delta will fix that. And the thrust that we apply is the maximum thrust. And the next thing we do is turn on the engine particles effect. So when thrust is being applied, there is some feedback for the player. This is actually where we'd add sound also for the thrust effect. So lastly, in the physics process function, if the health is greater than 0, we can roll. So I do allow you to roll if you are out of fuel, but if you're out of health, you're just going to lay there. And roll is calculated this way. Let me zoom out a little bit so we can see some more. So the proper way to get input like this in Godot is to subtract the input action strength for going left from the input action strength for going right, and that'll end up with a value of 0 if you are not giving any input, but if you apply either a keystroke or a joystick axis, it'll offset to either -1 or 1, depending on how far that axis is pressed, or just -1 or 1 if it's a keystroke. Next is integrate forces. And let's take a look at what we're doing here. State.transform, transform 2D to the vector to position X, position Y, actually moves things safely in the physics engine. And I'm doing it during integrate forces at a time when I have access to this state variable. So if we've moved by setting the position directly, not by applying a force, like it's not the same as applying thrust, but when we reinitialize, we set the position of the object instead of just moving it. We actually set the position. And by doing that, we have to have access to this state object, and we can do that in the integrate forces function. So once we've done that, we say I reset position is false, and move on to the next thing, where we're just going to check if the object has fallen below 740. We're just going to change the level and reinitialize. That is only ever going to run if we run this game by itself without if we run this node by itself without a parent game. If there is a surface, it can't fall below 740. So this is just in here for debugging purposes. State.setAngularVelocity. This uses the values that we calculated in physics process to determine if it should be rolling, if it should be thrusting. And this, where we apply impulse, is why we have an all or none value for our thrust. We don't have to worry about gradually increasing the speed of the lander, because the physics engine is going to do that for us. So we apply an impulse, and that impulse is rotated by the amount that we've rotated our ship. So that makes, let me maximize this. In game development, when you're moving objects around, order of operations is important sometimes. And here you can see we've got to rotate before we can move, because we need that rotated vector to know which direction our thrust goes. So after we've done that, we're going to check our position. This is how we rotate or wrap around the screen. If our position is less than the left side of the screen, which is 0, we transform to the right side of the screen, and vice versa if we're past the right side of the screen. So this variable move distance is just telling us how far we've moved in the last frame. And that's important because we're going to use that to calculate damage. So let's move down here. We've got if state get contact count is greater than 0. State.getContactCount tells whether or not a physics object has collided with another physics object. So here we can tell if we have run into the pad or the surface, because the very next line is if we have a contact count, get the first one, and we're only checking for the first one in this instance, get contact collider object, and we give it an index of 0, which is the first object. So if we're on the pad, we check that we're not rotated, we check that we're not sliding, and then we set a value, I am on the pad. If the name of the collided object is the surface, we set a value, if I'm not on the ground, we damage the ship and record that we are on the ground. I do it this way because we don't want the ship to continuously take damage when it's sitting on the ground, just when it initially contacts it. So I'm doing that to avoid constant damage. And then down here, the else statement for this: if contact count is greater than 0, do this, else mark that we're not on the ground and we're not on the pad. And that is the end of the lander code. And I'm going to make a quick change in project settings so that we run the lander game instead of just the lander object. And I'm going to start that. You can see when I start, everything initializes. I can control it the same as I could when I was running it by itself. And if I oh, something to note, the UI is connected. So as I use fuel, it's depleting fuel from this bar here. And that value is actually saved with the lander object. It's part of that object. The main game is looking up that value and feeding it to the UI. That's why the main game is the only one that references its children. So if I land here on the landing pad, it completes level 1 and gives me a little bit of a fuel reward. So let me go ahead and complete level 2. There we go. And here's what happens if we collide with the ground. You see we took some damage, and every collision takes damage based on how fast you're going, and dragging the ground is bad and leads to game over. And if you've run out of fuel, which I'm not going to, well, I can do it here. I'm going to speed up the video probably, but running out of fuel also ends the game. Okay, out of fuel. Game over. Okay, so everything's working. Let's take a look at how that actually works. And here we are in the main game script. Let's take a look at the changes that have been made since the last tutorial. Of note, I've added the lander to the ready function in the same way I did the surface and the pad in the previous tutorials. We no longer need these auto win, auto lose level functions, so I'm going to go ahead and delete them. And I've changed the if UI.iNewGame function to initialize the lander the same as it did the pad and the surface. Same thing for next level, just reinitializing the same as the other objects. So I'm not going to go into detail on that. We covered that in the last tutorial. Pause. So I've added pause to the main game loop. We already had a pause screen that would come up when we pressed escape, but it wasn't doing anything yet. So when that happens, when the UI state is set to pause, that's when I'm pausing the game. The appropriate way to pause in Godot, you don't pause individual objects, you pause the game tree. And the game tree responds based on what we set for those variables I showed you earlier, these pause mode process or pause mode stop values. Okay, so here all we have to do is pause or restart that tree based on the UI state. The UI can still respond because its pause mode is process. The main game loop can still respond because its pause mode is process. The lander will stop because its pause mode is stop. Very simple pausing in Godot. If the UI state is play, I have added some checks that check to see if the lander is on a pad, then it starts a counter. And that counter is multiplied by delta so that it runs at the proper speed all the time. And once that lander reaches a threshold, then we level complete. So if we're on the pad, we count up to a second and then brand new level. With health and fuel, we do something a little different. There is a death counter, which will count up as soon as we are out of health or as soon as we are out of fuel and have hit the ground. And once that death counter reaches its threshold, it changes the UI state to game over and resets the death counter. The last lines that we've added to the main game function just set the values of the health bar and fuel bar in the UI. So that's really all there is to it. So this whole game is complete. It's playable. There's probably more we could do to it, but that's all there really is to it as far as putting together a classic game like this. And every object we've built, we can reuse to make other games, including the UI. And I'm going to go ahead and play while I talk about this a little bit. The next tutorial, I'm going to discuss building probably an asteroids clone or a block breaker clone or something like that. But I'm going to reuse the UI object, and I'm going to show you how to build UI from scratch and then add graphics to it to give it a more modern or even maybe a 16-bit pixel art type look, whatever it is you want to build. But I'll show you how to apply that to this simple framework we built for making these classic games. So every time we want to make a game, it's much easier to prototype. And that's the big takeaway that I want you to get from my tutorials here, is I built this in a weekend, and over a period of a few weeks, I turned it into a video series. But actually writing code, the time involved is minimal. I did this in like a weekend. So there's a way that once you build this set of tools, you use reusable objects like a menu system for classic games, where you can sit down and just prototype anything you want, and you don't have to start by saying, okay, how do I get into the game? What's my UI like? How does pause work? You build yourself a framework, you use it over and over again, you reuse your objects, and you end up with this great library of pieces you can use in your projects, and you get really good at using them. So that being said, that's all I'm going to show today. I think we'll probably do one more tutorial on this classic Lander game where I'll do some things to add some polish, maybe add some graphics, but I think there's definitely some things I could do to polish it. And I think I'm going to do a tutorial where I actually embed this into a web page, because the Godot engine is great for distribution. You can go out on any platform, including just the internet. So we'll make a little web page, and I'll show you how to play your games in like a web arcade type of situation. So thanks. Let me know if you have any questions. Please like, share, and subscribe, and I'll see you next time.